Okay, one of the last things we have to talk about in terms of forces is gravity and weight. Now, I've mentioned these a little bit in some of the questions, and the two of them are linked. Gravity was meant to have been discovered by Isaac Newton when I think he's meant to be reading a book, wasn't he? And an apple um, fell onto his head. Science doesn't tend to work like that. It's very rare you get hit in the head and discover something brilliant. It's more likely he observed things falling. And he thought about how everything falls on planet Earth. And he said, well, what would happen if the tree was bigger? So if you had a bigger tree, would that apple still fall? And he assumed yes. He then thought about, well, what if you had a really, really big tree that actually extended all the way beyond planet Earth? Would that apple still fall? Would there still be a force producing that apple that would cause it to fall? And in fact, if the tree was infinitely big, would it still feel a force from planet Earth that would cause things to fall? And he assumed this, and he then went away and did a lot of maths, and he was able to prove that the same thing that makes apples fall to the ground on planet Earth is the same thing that causes the moon to orbit around planet Earth, because the force, so the moon's moving in this direction, the force of gravity from Earth actually causes the moon to move in a circle. And it's in fact the same force that causes Earth to orbit the sun. And he called it the universal theory of gravity. That gravity is this physical force that can um, cause things to happen all through the entire universe. It's the same everywhere. And he discovered two things from gravity. And one of the things he said was that if you have two planets and you were dropping an apple on one planet and dropping an apple on another planet, the mass of those planets has an effect on how quickly that apple falls. Or another way of saying this is how strong gravity is. So the more massive an object, the stronger the gravity that it produces. So they actually tested this on the moon. So they dropped objects on the moon and they fall much, much more slowly there than they do on planet Earth. But the other thing he said is the other thing that affects it is the distance you are away. So for instance, if we have Mercury and, well, you know what, let's do, forget Mercury and let's do Venus and Earth because they're roughly the same size and roughly the same mass. Sun produces gravity, makes these two objects move in an orbit. However, because Venus is closer, it will feel a bigger force than Earth. Okay, so the further you get away from an object, the smaller the gravity becomes. Now, on Earth, gravity, well, it's actually 9.81, but we tend to round it up, even up the GCSE, and just say, let's make it nice and round and call it 10. So gravity on Earth is 10 meters per second squared. And those of you that have been paying attention will notice those units. And the other thing that gets measured in meters per second squared is acceleration. Gravity is in fact an acceleration. It causes things to accelerate down to the ground. And what this means is that if you were, say, at the edge of a cliff and you drop an object, it accelerates at 10 meters per second squared, which means that initially, if the velocity here, speed is 0, after 1 second, it would have increased by 10, and its speed would be 10 meters per second. After 2 seconds, so after another second after that, it'll be at 20 meters per second squared, then 30, then 40, then 50, then 60. And that's what gravity does, okay? Now, the reason we're interested in gravity when we're looking at Newton's laws is Newton's laws depend really on the resultant force, and one of the forces that can contribute to the resultant force is weight, and weight is produced by gravity. And we have this equation that allows us to calculate weight. Okay, so this is the weight of an object in newtons. Okay, weight is a force, acts downwards. We use the word weight wrongly in day-to-day life. we would talk about weight in kilograms or stones or pounds, but in fact, when we're talking about that stuff, we're actually talking about mass, okay? And in physics, mass is measured in kilograms. So if we're using this equation, we have to convert from grams into kilograms if we're given it in grams in the question. And this is gravity, which is 10 meters per second squared on Earth. However, if you go somewhere like Jupiter, it's 25 meters per second squared. So it changes, and if you get further away from Earth, it would get less than 10. So we tend to assume that it's 10 unless you're told otherwise in questions, okay? And you would be expected to know that number, okay? It's not a hard one to remember. So the mass of an object is measured in kilograms. It just depends on how much stuff makes up that object. So if you have a mass of, let's say, 50 kilograms, we can work out the weight that you will be on planet Earth. So we can do weight equals mass times gravity. Weight equals 50 times 10. So your weight is 500 newtons. So if you're standing on planet Earth, not the scale, your weight will be 500 newtons downwards. Okay. However, if you were to go to Jupiter, okay, it's a gas giant, you're not actually going to be able to stand on the surface. But anyway, we could do the same equation there. Your mass doesn't change because it's just how much stuff makes you up. Be exactly the same. However, your weight will, because gravity on Jupiter is bigger, and therefore that will give you, what is it, 1,250 newtons. So in fact, on Jupiter, you would find it hard to even walk up set stairs if there's stairs there, because your weight pulling you down is so large. In fact, your heart would find it hard to pump blood up to your head. And that's really the important thing that we're going to have to take away from this lesson is that equation. Now, how it could be complicated is, let's say someone asks you to find the weight of a packet of crunchy nut cornflakes, mass 500 grams. I'm going to use weight equals mass times gravity, but the important thing is that mass has to be in kilograms. So the first thing I have to do there would be divide by 1000. We've been doing this for our RF equals MA equation anyway, so you should be used to it. Gives me 0.5 kilograms. Then I can put it into my equation. I get it's 0.5 times gravity on Earth 10, which gives us a weight, remember weight's a force, of 5 newtons. Okay, so there'll be a set of questions. Try them. Important thing is, this is going to be one of our last lessons. Next week, we'll do a few little videos that will just bring everything together. And then I'm going to set up a little online test for you. So you may, over the next week or so, just want to do a little bit of revision by maybe reading through some of the questions again from previous lessons, watching some of the videos in preparation for that. And then we'll have kind of a little, in America they'd call it a midterm test. But we're kind of in the middle of this unit, so we'll give you a little test just to see how everyone's getting on. Okay.